Hello everyone, this is Vikram and welcome to my channel. So today we are starting a brand new series, Python programming for AI and automation. So this is a comprehensive series that will take you from very basics of Python all the way to building real world applications in AI and automation. These are the topics that we'll cover throughout the series. We'll start with an introduction to Python, then set up our development environment by installing Python, and then practicing Python programming in Jupyter and Google Colab. From there, we'll move into fundamentals like variables, data types, typecasting, operators, strings, and then we'll get into core logic like control flow with conditionals and loops, data structures like lists, tuples, sets, and dictionaries, and functions. And I mean, in functions, we'll see a lot of things. And then we'll move on to understanding what are args, keyword, arguments, lambda functions, comprehensions, generators, decorators, and then finally, we'll see what is object-oriented programming in Python. In the final section, we'll see some of the advanced topics like exception handling, file handling, and using some of the modules like OAS, subprocess. We'll also see logging, files handling like JSON, working with APIs, multi-threading and multiprocessing, and many more. And we'll also see some of the data science libraries like NumPy, Pandas. We'll see how to work with databases and see how to create, or build REST APIs using libraries like Fast API. So there is a lot to cover. Let's get started with chapter 1. So in this chapter, we are going to cover the fundamentals of Python. So this will be a little theoretical but essential to understand all the internals of Python programming. First, we'll get a proper understanding of Python and where it fits in the AI and automation ecosystem. Then we'll understand how Python executes your code, the compilation step, the bytecode, and what is Python virtual machine. We'll also look at what it means for Python to be a dynamically typed language, and finally we'll see why Python has become the go-to choice for AI and automation work. So what exactly is Python? So Python is an interpreted, high-level, general-purpose, and object-oriented programming language. It is free, open source, and cross-platform. Means once you create Python programs, you can run on any machine like Windows, Mac OS, and Linux without any changes to your code. Of course, we'll have to set up the environment. One of the Python's biggest strength is its simple, readable syntax. It is widely considered the best first programming language for beginners, but it is also the #1 language for AI and machine learning. Organizations like OpenAI, Google DeepMind, Meta AI, and Tesla all rely heavily on Python. It powers the entire AI stack like TensorFlow, PyTorch, and scikit-learn, LangChain, Hugging Face transformers. All of these are Python based. Beyond AI, Python is also widely used in data science, automation, web scraping, API development, and basically to automate anything. The current version of Python is 3.14 as of this recording. And to be clear, Python 2 reached its end of life back in 2020. So everything we do in this series will be based on Python 3. And it also comes pre-installed on many Linux distributions, and for Windows and Mac, for other operating systems, it is pretty easy to install. Python comes with if you have to look at some of the features of Python, it comes built in high level data types like strings, lists, sets, tuples, and dictionaries. Again, we'll see all of these in the coming sessions. And it has all the standard control structures that you usually see in other programming languages like if else, while loops, for loops, plus other features that let you write very concise and readable code. You can also organize your code at multiple levels, like you can organize it in the form of functions, object-oriented programming concepts like classes, and then you can also break them into modules and ship them as packages. So Python is fully object oriented. In fact, everything that you see in Python is an object, and it is also dynamically typed, which means you don't have to declare variable types upfront, but you can optionally add some type-ins. We'll understand what are type-ins and why these are recommended for better code clarity and IDE support. And Python automatically handles the garbage collection, so you don't have to manage the memory manually like we don't have to worry about removing the unused variables and stuff, because garbage collection happens automatically. What really sets Python apart from our purposes is its massive AI and ML ecosystem. Libraries like NumPy, Pandas, Matplotlib, scikit-learn, TensorFlow, PyTorch, all are available through Python package manager, that is pip. Jupyter Notebooks and Google Colab have become the standard for AI experimentation and interactive development. Again, we'll see this when we set up the environment and when we practice various Python programs. And also, Python has a lot of packages support. So for everything there is a library. So literally you don't have to develop everything from scratch. There is a library for everything that you can basically download and consume. Gen of Python. Before we go further, it's worth knowing about this Gen of Python. These are a set of guidelines for the design of Python language, written by Tim Peters, who is one of the major contributors to Python. You can see them by running import this in the Python interpreter. So once you invoke Python interpreter, after you install it, you can simply type import this and see all the standard guidelines. Like it clearly mentions how do you maintain or write the Python programming. Like beautiful is better than ugly, explicit is better than implicit programming, simple is better than complex, flat is better than nested, readability counts, all these things, like having the documentation or doc strings. Okay, so these are all the various guidelines that we can follow while writing a better Python code. So before going further, let's understand how does a computer execute code. How does a computer sees your code, and then how it actually runs, and why we need compilers and interpreters in the first place. So the key thing to understand is that computers can only understand and run binary code, that is zeros and ones, which is also called as a machine code. Machine code is the lowest form of instructions that any CPU can directly execute, not the high level code which is usually written in English language or any other language. So CPUs doesn't actually understand this code. But as programmers, we don't write the binary, right? Because it's very hard to write in zeros and ones. Generally, we use high level programming languages like C, Python, Go, or Java that resemble human language. The problem is the computer cannot understand or run this high level code directly. We first have to translate or convert into binary code, that is zeros and ones, and that's exactly where compilers and interpreter comes into the picture. So they take your human readable code and then convert into binary that the systems can understand, right? So generally, languages whose programs are typically compiled are called compiled languages, like Go, C, and languages that we typically interpret are called interpreted languages, like Python. The best example is Python. And coming to compilation, compilation is the process of converting human readable source code into CPU understandable machine code that the CPU can directly execute. So when you write a program in C, C++ or Go, you have to compile it before you can even run it in that machine. The compilation translates your entire source code, which is written in high level language, into machine code, and upon successful compilation, it basically generates an executable file. Now the format of this executable file depends on the system or the architecture in which you compile the source code. So it can be an executable file with .exe extension on Windows, but in some other cases it will be .bin or simply without any extension. Basically that is an executable file. This executable file is tied to the machine it was compiled on, because of the dependencies on the hardware architecture, right? So the binary that you compile on one machine won't necessarily run on another machine. So if I take a Golang program and convert into a binary in Mac machines with, let's say, ARM architecture, it will not run on Windows machines with AMD architecture, right? Because it is not portable. One advantage of compilers is that because they process your entire program at once, they can catch syntax errors or any typos before you even run it. Like during the process of compilation only, it can check all those errors and simply you can fix them. Compile languages are generally faster and are more efficient to execute than interpreted languages like Python, because the code is already compiled into the machine code and you just have to run it. So there is no compilation that keeps happening whenever you run that code, right? Because there is an executable you can directly run on the machine. But on the other side, interpreter languages execute code line by line every time when you invoke it, right? So they execute code line by line at runtime, and are generally slow due to repetitive translation overhead, right? So this is how the compilation works, but there are other processes or steps inside compilation which we will not understand now. So if you take the C language, a simple basic code which prints hello world, okay, if it goes through compilation, it will basically generate, you know, a .exe file which is an executable file which you can directly run to, you know, run this program. So no need to run this program, so you just have to run the executable file. So interpreted languages, you know, they work differently. Unlike compilers, interpreted languages do not produce a binary executable file. Instead, each time you run a program, you basically invoke the interpreter, and it reads and executes the program one instruction at a time, that is line by line. Python is the best example of an interpreted language. Interpreted languages are generally slower, as we already discussed, because of its line by line execution by the interpreter. So we don't have any final executable, okay? And also, you know, since we don't have any compilation step here, it's very hard to catch those errors, okay? You know, so you can only see those errors when you run that particular program. Like if you take this Python program, even if there are some errors, you will not see them until you run it, because there is no compilation step involved to convert this high level program into machine executable. So how Python as an interpreter language works is, you know, if you think that there is no compilation step involved, so it's not like that. Unlike C and Go, which compile source code directly into machine code, Python takes a very different approach here. Your Python files, so usually they will be with a .py extension. They will be first compiled into a format known as bytecode, which is usually stored in .pyc format. This is Python, bytecode or compiled Python code. The bytecode is a low-level set of instructions, but it is not machine code. That's the reason why, you know, CPU cannot directly run this bytecode. Instead, the interpreter, like, you know, the Python interpreter takes this bytecode and run it right on that machine, right? Usually the Python interpreter is also known as the Python virtual machine, or PWM. You may have heard this virtual machine in Java as well, which is called Java virtual machine, right? So when you run a Python program, usually two things happen. First, the source code is converted into the bytecode in .pyc format. Second, the the Python virtual machine, which is also known as the interpreter, take this bytecode and execute it. Generally, if you look at the your folders where you have the Python code, when you try to run them, you will see specific folders like PyCache. This will have the Python compiled code or the bytecode. Okay, then what is dynamic typing in Python is in static typed languages like C, C++, or Java, you have strict requirement that you need to declare every variable before you assign a value to it. Okay, for example, if you have a variable a is equal to something known as machine learning, so a becomes a string, so you need to declare that a variable as a string. The compiler validates these types at the compile time, but Python works very differently. The interpreter doesn't check the type of the variable that you are using at the runtime even, right? Sorry, at the static time, but during the runtime, it will check. But the thing is, the type of the variable is allowed to change over its lifetime. So I can just say a is equal to 1, which is an integer, but later I can change it to a equal to machine learning, which can be a string. So you can dynamically change the type of the variable during the runtime, right? This gives a lot of freedom and makes writing code better and faster, but it also means certain bugs will only surface when the code actually execute, right? Because the variable is allowed to change, so this may also introduce some bugs which can only be identified during the runtime. Okay, modern Python versions like from 3.5 also supports type hint. So you can annotate your functions with expected input types and then the return types. For example, here this function takes input string and output string, but you don't even have to have this. You can simply just say diff greet. Inside the bracket you can just say name without any type ins. Still that works, but we can have these type ins. So anyone who is using these functions knows that the input that is expected is string and the return value of that function is also a string. So this is a difference between statically typed and dynamically typed. So you can see num1 is 10, num2 is 20. So we need to declare them as integers here. But in case of Python, you don't have to do this because Python does this checking during the runtime, and then the type of the variable is allowed to change, right? Yeah, so why Python for AI and automation? So why has Python become the dominant language for AI and automation? There are, you can say these four major areas where Python excels. So in AI and machine learning, you can build and train models using frameworks like scikit-learn, TensorFlow, PyTorch. You can fine tune and deploy these large language models and do natural language processing using probably Hugging Face transformers. In generative AI and LLM based applications, Python lets you build AI agents and chatbots using LangChain or Llama Index. You can work directly with AI APIs from OpenAI, Anthropic, or Google Gemini. And concepts like prompt engineering and retrieval augmented generation all can be implemented basically in Python. Of course, you can also do this in Golang as well, but Python is more dominant in this space. For data science and analysis, pandas, NumPy handle data manipulation, while Matplotlib or Seaborn and Plotly cover the visualization part. Like you can visualize your entire data set. And for general automation, Python is ideal for automating repetitive tasks like file handling, web scraping, API calls, or system testing. So it handles workflow automation, scheduling, notification, and even infrastructure and cloud automation scripts can also be written in Python. And coming to Python for AI and automation, at the foundation, you have core libraries like NumPy, Pandas for data handling, and for visualization you have Matplotlib and Seaborn. For machine learning you can have scikit-learn cover classic ML algorithms, while TensorFlow and PyTorch handle deep learning. Hugging Face provides access to thousands of pre-trained models. We'll also see this in our AI series. In the generative AI and LLMs, LangChain and Llama Index are go-to frameworks for building LLM powered applications. And OpenAI and Anthropic SDKs lets you integrate their APIs directly into your code and let you build AI agents. For automation, we have libraries like Request and Beautiful Soap for web scraping and HTTP. Selenium and Playwright cover browser automation, and libraries like Schedule or AP scheduler manage task handling. And for your development tools, like we also have Jupyter Notebooks, Jupyter Lab, and Google Colab for interactive development environments. We'll see this in the next section, and also while practicing some of the Python code. And we also have VS Code, which is an IDE with a lot of Python integrations, plugins, right? And finally, for package management, you have Pip, Conda, or UV, so you can better manage the Python environments. This wraps up chapter 1 of Python for AI and automation. In the next video, what we'll do is we'll see how to set up Python by installing Python on Windows, and we'll also set up VS Code and see what all Python plugins are available for VS Code. And then we'll also explore Jupyter Notebooks and Google Colab for interactive Python development. Thank you, and see you in the next video.